Hello, students. And a question to demonstrate different number bases. So again, there's the many different algorithms sheet that is posted, but to kind of walk through the steps for at least one of those. So I'm going to go ahead and do that. I don't want to pick a base that's too small because in the multiplication, it actually is, there's almost nothing to do. Like if you choose base 2, then you're either going to get a 1 or a 0. So there's not a lot of kind of the thinking process that goes on. There's not a lot of regrouping. So what I want to do is do one that is a little bit higher than that. So let's do base 6. And let's do something like 5, 3, base 6. And we're going to multiply by 4, I don't know, 4, 5, base 6, I guess. Okay. So again, you have to be thinking in base 6. So we're taking groups of 6. Now I want you to understand. So I'm going to do two different algorithms here. And let me see here. Let me grab all of this and just kind of drag it over. So I'm going to do one algorithm over here. Then I'll do the traditional. We can also do the lattice if you want, but the lattice actually is quite a bit more confusing if you're trying to explain the place value notations. And not to say that it doesn't work. It works just fine. But you just have to kind of be aware of how you're grouping things. So we're going to go ahead and do this as um, base 6, and I'm going to go ahead and do partial products. Okay, so I'll put that at the top. Partial products. Now remember, partial products as we go through, 3 times 5 is still 15, but 15 would be two groups of 6. Two groups of 6 is 12, and 15 would be 3 left over. So 2, 3 is what I would write down. 5 times 5 is still 25, but 25 is 24 plus 1, which is 4 groups of 6 and 1. Now, again, this was 5 times 5 would just be 4, 1, but I have to move it over because, again, if you think about what I'm multiplying here, I'm multiplying 5 times 3. The next one is 5 times 5, 0. So when you combine these together, and we're going to do that and show that in the traditional, then this would be 5 times 5, 3. Okay. But again, as we're kind of going through it, the next one up would be, looks like 4 times 3, but remember we're moved in a place value. So we're in the 6s right now. So 4 times 3 is 12, and 12 is 2 groups and 0 ones, 2 groups of 6 and 0 ones in the next place value, because again, I'm multiplying by groups of 6. So I put it in that next place value. And lastly, I move over, and again here, I'm multiplying by a 0 and a 0 because it's going to be 4, 0 times 5, 0, which is 20, and 20 is 3 6s and 2. Okay, so again, what am I multiplying here? The next one's going to be 4, 0 times 3, and the last one is 4, 0 times 5, 0. These in the traditional will combine to be uh, 4, oops, I started writing a 5 down. 40 times 53. And then the reason what we do, of course, if we add these together so that the end result, now I'm grouping 53s together, right? So the first one I was grouping, I had 5s. I had 3 5s and 55. So that gives me 53 5s. The one after that, I had 40s that are kind of the common piece. That's why I wrote that out in front. Maybe I should come up here and do a different color. I'll do purple. Purple here, purple there. But now I see I have 53 that is common. So when I bring that together, it's going to be 53 times 45. So again, 4, 5 being the operative word here. 4, 5 times 5, 3 is my final result. Now, of course, as I'm finishing up on the left-hand side, which is just fine. Let's see here. Get over there. There we go, thing. Then I want to do add these together. So I get a 3. 2 plus 1 is another 3. 4 plus 2 is 6. That's one group of 6 and 2 ones. And then 3 and 1 is 4. So my final answer would be 4233 base 6. Okay. Awesome. Love it. Okay, so now let's come over and do the traditional. So the traditional is just fine. It's the same multiplications, we're just going to be grouping things a little different. So when I take a look here, 5 times 3, I would get 15, which is 2 sixes and 3 ones. So what I do is I regroup up here. Now just remember that this 2 that we're looking at, this 2 represents 2 groups of 6. In the base, since we're dealing with base 6, 6 is a 1, 0 in base 6. So I know it looks like 10, but it's not. It's just whatever your base is. You're just used to a base 10, and they all look the same. They just really mean base. Okay. Next up, I would do 5 times 5 sixes, which would give me 25 sixes, plus 2 more sixes would give me 27 sixes. Well, 27 sixes would be 4 groups of 6. 27 would be 24, and 3 remaining. So now what am I kind of bringing over to you? If you look, this 4, 3, 3, I'll put a little star by it here. That is this component right here, which now just follow it all the way over. Isn't that the same thing as if we just add those two together? So what I want you to get at here is that the 2 that is here, the 2 groups of 6, is the 2 that you're kind of writing up and above. Okay. All right, so again, let's jump back to traditional because we're doing traditional. Now I want to multiply by 4 groups of 6. If you multiply by groups of 6, you're not going to have any ones left at all. You can't because you have groups of 6. So 4 groups of 6. 4 groups of 6 times 3 gives me 12, which is 2 additional groups. Poor choice on my part because it is another 2. And there would be 0 remaining. Let's see here. And then 4 groups of 6 times 5 groups of 6, which would be 20 groups of 6 squared, plus another 22 groups, 22. But if I'm doing groups of 6, 4 groups would be 24, so that's too much. So I need to go 3 here, and that is 3 of 6 is 18. And remember I had 22, so I should have a 4 here. Okay. So there's my final piece. So if you want to kind of take a look at it then, okay, so take a look at this 3, 4, 0, 0. Take a look right here, which is also the same thing as just doing these two together. 3, 2, 0, 0 plus 2, 0, 0 is 3, 4, 0, 0. And at the end, I can just add these together. 3, 3. This is 8, which is 1, 6, and 2 ones. And I get the same thing, 4, 2, 3, 3 base 6. So I think if you were to kind of explain what does this 2 represent, this 2 represents 2 groups. So think about where it came from. It came from over here, right? 2 groups of 6 times 6. So this would be the same thing as 10 base 6 squared. So 10 base 6 squared is what we're dealing with here. Now, again, the reason that they're in the tens place is because in the tens, I'll say tens because we're kind of used to it, but it's really your base place or your groups of 6 because I'm multiplying by groups of 6. And so when I multiply groups of 6 times other groups of 6, I do end up kind of moving those into the 6th place. But again, all of that is moved in by 1 place value because 0 is indicating multiplication by 4, 0. And again, the 4, 0 comes from right here. 4, 0 is what I'm multiplying by, so I will never get any ones. We know when we multiply by 10 in our traditional base, we have to put a 0 in the ones place. And the same is true in any base system. When you multiply by the base, you are moving in 1 digit. So there's kind of 2 quick approaches. I said I'd do lattice as well, which is fine. So again, 5, 3, and what did I do? 4, 5. Okay. Make the little box. And then just do your single digit multiplication. 4 times 3 is 12. That's 2 sixes and 0 ones. 5 times 3 is 15. 15 is 2 sixes and 3 ones. 5 times 4 is 20. 20 is 3 groups of 6 and 2 ones. And 5 times 5 is 25, which is what? 4 groups of 6? That would be 24 and 1 here. And then you just kind of bring everything down as you go. So this becomes a 3, add down here. 2 plus 1 is 3. Add down here, 4, 5, 6, 7, 8. Well, that's a group that I have to regroup, and my end result is 4, 2, 3, 3. Now, if you're really paying attention, every bit of what's in here shows up in the traditional algorithm. You should see a 3, 2 that is moved over 2 place values. So you should see a 3, 2 that's moved over 2 place values. You should see a 3, 2, 0, 0. You should also see a 2, 0 moved over 1 place value. So you should see a 2, 0 that looks like this. You should see a 4, 1 that's moved over 1 place value. So there should be something like this. And lastly, you should see a 2, 3 that is not moved over at all. Basically, it's exactly the same thing that we saw when we did the other algorithms. So there you go. That is the approach to kind of understanding these pieces. I think the partial products is really helpful, especially as you transition into the traditional. Once you get used to the traditional, it's actually pretty quick because it's the exact same thing you've been doing. So I know I did base 6. You might have wanted this in base 10, but again, it doesn't matter which base it's in because whatever base it's in, it's base 1, 0 for that base. So that should do it. Hopefully that helps. All right. I'll see you soon. Off you go.